Hey, how's it going, guys? So here we are back again at the Python BACnet Stacks Playground. Gonna get a little bit into Rust now. That's kind of my new special interest. I can show you a little bit about what's going on in Open-FDD along the way too. I also have to apologize a little bit as my microphone is it's very quiet. So kind of apologize a little bit, like if the videos are coming through very quiet. I have all the settings kind of cranked up as high as they can go from what I can tell. But yeah, so let's do a little bit of Rust today, and I apologize about the sound. Just a little bit of updates. We'll try and do this a little bit every day on Open-FDD. So it's also getting rewritten in Rust. No more Python. Python is like a great prototyping language where we prototype the heck out of Open-FDD used like heavily for fault detection purposes, which we'll get into a little bit along the way as well. But Rust is more like that professional compiled language that you can take a prototype into a real professional grade application. So Rust is kind of like a new cool kid on the block, I think, as well in systems programming. I'll get into this a little by little about Open-FDD, but we're also publishing GitHub packages directly. So this is also published to the GitHub container repository daily on Docker container builds. There's still a ton of bugs in building going every day for Open-FDD. But yeah, it's kind of looking like this. I have my developer console open. You'll be able to do SQL queries to do fault detection in here, make plots, and then also ingest CSV files, BACnet, Haystack, Modbus, and JSON API. Everything's all in Rust now. There'll be like a dashboard, and then you can also chat with codecs. So I have the codecs codex CLI is kind of running in here, and you'll also be able to use Cursor, Olama, OpenClaw, whatever you want. So also we'll get into this way later is Open-FDD's handling the data modeling in Rust with the Oxygraph project. So yeah, it's all coming. Okay, so like what I wanted to show a little bit today is Python BACnet Stacks Playground, where we did a ton of Python. We did a lot with Backpipes 3, Back 0. This is how we prototyped Open-FDD version 2, all of the BACnet drivers. It was enough that AI agents could then turn that into drivers for a framework. So we're doing the same thing with Rust. And so I'm just kind of scrolling down here. These are all of our vibe code app checkpoints. I do have some of this already prototyped in Rust so that I know that it works, and we're getting there. So, but today I just wanted to cover a little bit of the Rust theory lectures, and then we'll slowly get into the Rust BACnet stack. And then also some future vibe code app checkpoints. Getting a little bit into the Rust Haystack, maybe the Python Haystack project too. And then also some other people have on my Discord channel has expressed interest in like kind of a do-it-yourself data lake. So some people want to test Open-FDD, but they don't want it to integrate directly to their billing automation system. So they're building like they're calling it like a do-it-yourself data lake. So basically, you're scraping data from one instance is a Niagara server through Haystack, and then putting that data into a Postgres database, which is just a flavor of SQL. So it's just like a big time series database, raw, messy data in it. And then I can query that information into Open-FDD. And then there's actually kind of like, it's in the middle, basically, kind of keeping that live building automation systems safe, and then I can dink around with Open-FDD in a read-only do-it-yourself data lake kind of in the middle. So we'll kind of cover that concept as well. It's coming. I don't know when, but also want to do a little bit of bare metal embedded BACnet stack work, maybe some stuff in Modbus, a little bit of BACnet routing too. So it would be nice to do a little bit about study BACnet routing, because it's kind of like an important concept, especially in big campus environments. If you run across, it can be networking nightmares for BACnet systems integrators. Okay, so yeah, we did a this is not active anymore, but I was playing around a little bit with AWS IoT Core with MQTT and pushing data up to AWS. And you can play around with it for free. Watch some of the YouTube videos on it, but that's going to go inactive here. Okay, so let's just go back into our computer science lectures. So we did this all in Python, and then we're going to try and recreate that all in Rust. So this is just going through just like kind of like the bare bones Python, just getting into syntax and operators, which can be greater than, less than, math operators, like how to do some basic file operations in Python. We covered that, strings, data structures, and then also we're just jumping right into Rust next. So we're going to go right to day 28 and how to install Rust, which this will work just fine in Windows too. So if anyone is on Windows, it'll work just fine on Windows. But I'm going to be running mine on a little Raspberry Pi right on my test bench here too. So we'll be kind of like doing the same thing we did in Python. It's going to just be a crash course though on like syntax, operators, control flows, getting into it. Gets more complicated because Rust is like a lower level language. It's typed language too. So with Python and JavaScript, you don't have to worry about declaring a float or an integer or a Boolean. It does it all. It's a scripting language. But Rust, you have to do define variables, the data type, and then also it's a compiled language, where Python is an interpreted language, so it compiles at runtime. Kind of two important concepts is like Rust, like what we're doing with the GitHub container repository. Like I can compile a big executable file for Open-FDD and then ship it. So you can do that with Rust too, in C and C++, Java. Modules in the Niagara framework are compiled Java jar files, where Rust has something similar. So it's a compiled language where there's lots of, when the code gets compiled, there's lots of safety mechanisms and checks that get built into that. So I think like Rust is like really taking over for C. So Rust is taking really over into C. It's taking over C. So they're rewriting the Linux kernel in Rust. And it's a compiled language, super fast like C is. And then there's also like safety mechanisms in there too, where I think like this gets over my head, but I know enough at a high level is that hackers and cybersecurity, they can not only manipulate networks and network logins and all that kind of stuff to authentication, but really advanced ones can manipulate computer memory. So C and C++ and probably some other languages, you have to do memory management manually, where Java and Python, it handles that all behind the scenes. in all the memory. You don't have to worry about memory management in Java or Python. Um, but in some of these other languages, computer hackers can manipulate memory management. And I think a big thing when Rust was designed as a tool is that they incorporated all of the vulnerabilities of C. They're going to correct in Rust when it comes out. That's probably not too terribly different when I think the history of BACnet, this is before me, but Modbus had some issues like that too. And then, to my knowledge, when they designed BACnet in the 1990s, it was on the concept that it would be better, faster, stronger, easier to work with than Modbus. So kind of think of it like that. Rust and C, BACnet and Modbus. It's probably a bad analogy, but one that people can at least relate to if you work in the HVAC industry. So what I want to get into in Rust is network programming in Wireshark. So this is kind of getting into bits and bytes on the wire. So it's a specialty of software engineering, programming. So some people might specialize in web apps or AI engineering or um, desktop applications. And then network programming is its own specialty. So they're the people that are creating network stacks. Like the Wi-Fi router in this office has some network stack running in C or C++ that's doing all the bits and bytes on the network. And BACnet is one of those concepts too. MQTT, whatever. Like people create a network stack, and then network programming is a very niche um, genre of programming. It's very complicated too. I think to me, it's really complicated. I only understand it at a high level and need to understand it better. But if you Google like network programming, there's books on it. So like you can see network programming in C. There's books. I've read books in Rust, and then C sharp is another one too. You can get into that's what Yabe is written in. So uh, there's network programming in C sharp, and that's what the Yabe tool is written in a BACnet stack in the C sharp language. So yeah, I think there's network programming concepts in every coding language, even Python, which is a scripting language. Um, and then Rust is the one that I want to specialize in because it's kind of the cool new hip thing to do, and it's kind of a thing of the future too. I think Python and Rust is a really good combination to master, especially in this world of smart buildings and IoT. So we'll get into studying a little bit of that, Rusty BACnet, and yeah. So we have some of these apps made already. I do for Open-FDD, and we'll get into more of Haystack. And then once we get into day 55, this is something Open-FDD is using, is a graph. Gets into from network programming into graph theory, which is advanced data structures. So it's all coming. Yeah, so gets complicated fast. This is probably master's degree level of computer science topics that we're covering here. So let's go right into day 28 of Rust. How to install Rust. I have Rust installed already. So, whoops, sorry. So like, if you go to the Python BACnet Stacks Playground, just go right into lessons and then go into day 28. Day 27 was where I left off a while ago now. Just when I was thinking about getting into more Python and algorithms, kind of change of plans here. So like some people study and specialize in algorithms exclusively, where we only touched on it bare bones, bare minimum, hardly at all. So like in IT, you might not study algorithms hardly at all. You might just use coding languages for automation purposes. But if you were into machine learning is a very advanced algorithm. There's even mechanical algorithms for HVAC optimization, like Guideline 36. So algorithms is a very important topic, and um, don't skip it like I did here. Okay, so like I'm here in Bash and Linux on Raspberry Pi, but you can do this in PowerShell and it'll work fine in Windows, and it'll make a .exe for you. If you have a sometimes if you have if your company has really strict uh, like virus scan tools, it might not be happy letting you run Rust on it. But so I already did this I'm just running on a Raspberry Pi right here in VS Code. So I just can clear you and then just so I did this command already, and then it installs Rust. And there might be like a command in there where you just push one. There's 3 different options. Push 1 for normal Rust install or something like that. And then if I'm just going to copy this and then run this. So this is the latest version, I guess, 0.196.0. So Rust C is taking over for C. That's Rust. And then Cargo is the package manager. So like when we made tools in Python, it was with pip, and Rust uses Cargo. JavaScript uses one called npm. I'm not really sure what Java uses, but I'm sure every coding language has one. Okay, so let's create a new Rust project with this --bin argument. So cargo new BACnet lab. So it created a binary application. So this is be an executable Linux operating system file. If you were on Windows, this would pump out a .exe. Cargo run. So it's compiling on the Raspberry Pi. It did it already, and it made a little hello world. So this is what Rust projects always have, is they have this src directory for source and then a main.rs. I think if we were working in C projects, there would always be a main.c. Like there's a main function and a main C, and I think Rust adopts some of that stuff from C, I think. But when you bootstrap a Rust project, it does hello world. Okay, so project layout. Main entry point, just like in C, I think, is the main function, and then cargo toml file. So this is the toml file, which I think when we get into network programming, we'll add in packages, dependencies. Like in Python world, this was backpipes and back0 in CSV, whatever. Okay, why this matters. Field gateways, modern edge stacks, Open-FDD, Rusty BACnet, Rusty Haystack, ship has compiled Rust services, not interpreted Python scripts. So we talked about it a little bit. Python is a scripting language. It's interpreted, where Rust is compiled. So it compiles it into a binary, a .exe if you're on Windows, and you ship that. Where when a Python project ships, you just ship files, and then you compile and it runs at runtime. It compiles at runtime. And then cargo is how you build them. Okay, so let's just change this print statement. Main.rust. And then we can run this again, and it'll I think we can just go cargo run. All right, it compiled the program again, and it printed the string here of the IP address. Key takeaway: cargo new and then cargo run is the Rust equivalent of Python script.py, but you only get a standalone binary you can deploy on an edge host. So I think they're trying to say is Python or Rust is compiled and Python is interpreted language. So Python compiles at runtime when you run the programs, which we did lots of that on the prior YouTube videos. Okay, so that's all for today, guys. And then tomorrow we'll get into Rust types. So Python, we never even had to worry about this, all these different data types. And this will get pretty hard fast. So this honestly looks like what the BACnet stack in C looks like, which is really hard. So it should get pretty hard fast. So I'm a little bit nervous, but like I think this is good stuff to learn. So hope you guys are liking this. Stick around. I'll try and show little updates on a daily basis of Open-FDD along the way as well. So see you guys tomorrow.